Section 1.5 is about energy, and we are going to talk about this for an entire chapter or more later on in the semester, but for right now, we're just going to talk about it a little bit more briefly. So the first thing we want to do is define what we mean by energy, and in this case we mean the capacity to do work. So if this particular man here has energy, it means that he has the capacity to be able to do something that is work output. So what does that mean? Well, when force is applied and acts through a particular distance, so this person is putting force against this box, which moves at a certain distance, we can say that work has been done. Some sort of force has moved along a certain space, and that's what work is defined as. Work through force through distance. We can also think of energy in terms of its conversion from different forms. One example, for instance, that we hear a lot about is potential versus kinetic energy. Potential energy is just the energy something has because of its position. So it has the potential to do work. It has the potential to cause some sort of force over a distance. Due to position. So this 10-pound weight on top of a building has much more potential energy than the weight once it's fallen off and hit the ground. On the way down, it has kinetic energy, which is movement-related energy. So this has the potential to hit something else and cause a force to move over a distance and provide work to occur because of the nature of its motion. Just like this had energy at the top, because of its position, it could fall, it could strike something, gravity could pull on it and cause a force over a distance. The speed and the momentum of this object has that same capacity to do work, so therefore it has energy, but it's motion energy. So as this falls, though, the speed picks up and has more and more kinetic energy, but less and less potential energy because it's lower and lower compared to where it started. When it hits the ground, the potential energy has been used up, and the force of the impact dissipates into structural deformation of the sidewalk. It might chip, break, or bend, and there's sound energy given off and heat energy given off. Sound and physical changes to the structure of that sidewalk. It could break. So that energy is transferred from potential to kinetic to heat, sound, and other things. Another way we can think of conversion of energy is where we have chemical energy. We have molecules that exist in a certain chemical configuration. It means their connection, their connectivity, has a form of potential energy that we refer to as chemical energy. That's the energy in bonds, in the attachments of one atom to another. What can happen is these bonds can rearrange to a more stable configuration, and that energy, that difference between the less stable and the more stable configuration of attachments results in a release of energy to the system that it is working in. So this energy in bonds rearranges to some lower energy state. The excess energy is transferred to some other object or process. Or 2 R's, 2 F's, I don't care, whatever, I can't spell. But in any case, in this example, we have molecules in gasoline, which is this long connected chain of carbons. So a whole bunch of carbons, and then there's actually a whole bunch of hydrogen surrounding that as well, in this nicely ordered, long, extended chain. However, in the exhaust, we've mixed with oxygen and now we have carbon and oxygen, small molecules with a couple of bonds in them. And the difference in energy between how energetic the molecule put together is in gasoline to the amount of energy in the bonds holding together carbon dioxide, we actually have less energy present in the bonds of carbon dioxide. So the extra energy is converted through explosions and release of heat that turns a cylinder, turns an axle, turns the tire, and there's a force applied over a distance and work is performed. So that energy, the chemical energy present, has the potential to allow for work to be done in the movement of the car. One of the laws that we talk about is the law of conservation of energy. So remember back in the chapter about what the different forms of the scientific process were, the different steps, what a law is. This is the law of conservation of energy. And what that states is that energy is only exchanged between different forms. And we never destroy energy and turn it into nothingness and use it up. We never get energy from nothing and just create it specially and as new energy. So all it does is change from one form to another. And anything you can think of is just an example of energy moving from one form or another. So we just saw this example that we had of gasoline being used up, the chemical energy being used up, but it's not really being used up and disappearing. It's turning into motion energy, kinetic energy, and it's turning into heat energy. So it's being transferred from chemical bonds to heat and motion. Plants, a tree for instance here, takes the energy from the sun, light energy, and it can use that and turn it into chemical bonds and sugars and molecules that have energy and photosynthesis, and we end up with conversion of light energy to chemical bond energy, which if it makes fruit or vegetables or that sort of thing, we can then eat and turn the bonds chemical energy back into movement energy and heat energy by using it in our bodies. You can have hammer, which is kinetic energy, and that changes this mechanical energy of movement into deformation. It moves the molecules, pushes them aside, makes a hole, and heat energy. That space will actually get warm as well as this happens, as energy disperses into it. And we have all sorts of electrical into light or electrical into motion. None of the energy is actually lost or disappears. All it actually does is change forms. Okay, so just to summarize here, what we see with energy and we want you to know about so far before we get to the full chapter that talks about this stuff is that energy actually only changes forms. It's not created, it's not destroyed, it just goes from one type of energy to another. The other thing we want you to know is that high energy tends to disperse into multiple forms of low energy. If I have that object on top of a building, it falls, it moves, it stops, it heats up, it makes noise, it cracks the pavement. So that high potential energy is now dispersed into a lot of smaller packets of different types of energy. And that worked with all of the examples pretty much that we saw previously.